Salam uşaqlar, axşamınız xeyir, necəsiz? Bugün deməli 40-cı gündür. 40 gündür işsizəm və 40-cı gün yayınla davam edirik. Deməli. Bir neçə dəqiqə gözləyək. Mən çek edeyim hər şeyi, ondan sonra davam edirik. Hə, əla. Uşaqlar, deməli bu dəfə multitrading ilə bağlı bir-iki şey oxuyacağıq. Görək necə keçəcək. Yaxşı keçər yəqin ki. Deməli. Əvvəlcə GPT-dən soruşdum ki, mən multitradingi öyrənmək üçün hardan başlamalıyam, nə etməliyəm? Gəl buna cavablar verək ki, Java, are you interested in low-level thread programming or high-level concurrency abstraction? Both deyək. Do you want to explore topics like synchronization, deadlock, memory models? Yes. Dördüncüdə də paper textbook potential post deyək. Bu search-ni eləsin. Biz də əlimizdə olan mənbədən baxaq. Bir deməli Oracle-ın bu dokumentasiyasına baxdım. Burada yazıb biraz hansı ki eynidir. Bir də belə bir vulkan guide belə bir şey var. Amma bura baxdım. Gəl buradan davam edək. Deməli, this section introduces basic concepts of multithreading. In multithreaded process on a single processor can switch execution resource between threads, resulting in concurrent execution. Concurrency indicates that more than one thread is making progress, but the threads are not actually running simultaneously. Switch between the threads happen quickly enough that threads might appear to run simultaneously. In the same multi-threaded process, in a shared memory multiprocessor environment, each thread in the process can run concurrently on a separate processor, resulting in parallel execution, which is true simultaneous execution. When the number of threads in a process is less than or equal to number of processes available, operating system threads support system ensures that each thread runs on different processor. For example, in matrix multiplication that is programmed with 4 threads and runs on a system that has 2 dual-core processor, each software thread can run simultaneously on the 4 processor cores to compute a raw 4 thread system that has 2 dual-core processors. 2 dual, deməli, each software thread can run simultaneously on the 4 processor cores to compute raw of the results at the same time. Traditional Unix already support the concept of thread. Each processor contains a single thread, so programming with multiple processors is programming with multiple threads. But process is also an address space, and creating a process involves creating new address space. Creating a thread is less expensive than creating new process. Because the newly created thread uses the concurrent process address, the time that is required to switch between threads is less than time required to switch between process. A switch between threads is faster because no switch between address space occurs. Communication between threads of between threads of one process is simple because the threads share everything. Most importantly, address space. So data produced by one thread is immediately available to all other threads in the process. However, this sharing of data leads to different set of challenge for the programmer. Care must be taken to synchronize threads to protect data from being modified one or more than one thread at once, or being read by some threads while being modified by another thread at the same time. Thread synchronization, the user level threads, primary programming interfaces in multi-threaded programming, visible only from within the process, where the threads share all process resources like address space, open files, so on. Following state is unique to each level: thread ID, register state including program counter, stack, signal mask, priority, thread private storage. Deməli, hər bir thread-ə spesifik olan thread ID, register state including program counter, instruction pointer ya da belə idi deyəsən, stack pointer. Stack pointer daha doğrusu instruction pointer'dır. Stack, signal mask, bunu bilmirdim. Priority, hər bir thread'in öz priority'si var. Thread private storage. Threads share the process instructions and most of the process data. For the reason, a change in shared data by one thread can be seen by the other threads in the process. When thread needs to interact with other threads in the same process, the thread can do so without involving the operating environment. Nə deyir? Deməli, thread digər threadlərlə prosesin içərisində digər threadlərlə interact etmək istəyəndə operating environment-ı involve eləmədən bunu edə bilər. User level threads are so named distinguish them from kernel level threads, which are the concern of system programmers only. Because this book is for application programmers, kernel level threads are not discussed. Yəqin ki, kernel level threads hələ ki bizə lazım deyil. Deməli, thread scheduling. Deməli, POSIX standards specifies three scheduling policies: first in, first out, round robin, and custom. First in, first out is queue-based scheduler with different queues for each priority level. Round robin is like first in, first out, except that each thread has an execution time quota. FIFO and round robin are POSIX real-time extensions. Threads executing with these policies are in the Solaris real-time scheduling class. Special privilege, default scheduling policy, executing with other policies are in traditional scheduling class. Namely, the interactive time share class, fair share class. Bunlar nədir? Fixed priority class. Such specialized class are not discussed here. Two scheduling scopes are available: thread scope, process and system process scope and system scope. Deməli, scheduling scopes, process scope və system scope. Threads with different scope states can coexist on the same system and even in the same process. Eyni sistemdə müxtəlif sistem skopu olan threadlər mövcud ola bilər və eyni prosesdə də müxtəlif state olan threadlər mövcud ola bilər. Process scope calls such thread to content for resources only with other such threads in same process. Process scope calls such threads to content for resources only with other such thread in same process. Process scope eyni prosesin içərisindəki digər threadlərin resurslarını nə edir? Yarışır. Resource üçün yarışılır yəni. Proses skopunda eyni prosesin içərisində proses skopu olan threadlər həmin prosesin resursu üçün yarışırlar. System scope calls such thread to content with all other threads in the system. Sistem skopu sistemin içərisindəki digər threadlərin bir-birindən yarışmasına səbəb olur. Amma proses scope prosesin içərisindəki threadlərin resource üçün yarışır. Race. In practice, beginning with Solaris 9 release, system makes no distinction between these two scopes. Thread cancellation. A thread can request termination of any other threads in the process. The target thread, the one being cancelled, can keep cancellation request pending as well as perform application-specific cleanup when the thread acts upon the cancellation request. Deməli, cancel olunacaq olan thread cancel request'i pending edə, həmçinin application-specific cleanup perform edə bilər. Nə vaxt ki thread cancellation request'i deməli perform edərkən onu pending vəziyyətində saxlayıb application-specific cleanup permits either a single bu nə deməkdir? Əla, bir sürü resurs. One thread in a program can ask another thread to to stop running. But the thread that receives this please stop request doesn't have to stop immediately. Instead, it can hold on to the cancellation request until it reaches a safe point. While doing that, it can also run specific cleanup code. Okay. Yəni bir thread digərindən stop eləməyini istəyir. Həmin stop edilməsi istənilən thread həmən bu requesti deməli perform eləmir. Onun yerinə biraz gözləyir ki, safe point çatsın. Bu arada da həmin requesti hold saxlayarkən nə edir? Clean up edir. Thread, worker thread is interrupted, do some work, cleanup happens here. Ne diyor? Interrupt olmayıpsa devam edir. Another thread request cancellation. Burada clean up edir, sonra da artık bu dayanır. Burada bitir. Okay. Save work. Cache'de de clean up logic. Rest ne diyor? Reset the flag if needed. Long running task, clean up resource. Any thread can request cancellation. The target decides when to act and can clean up. Java, you can use interrupt as a request signal. The target thread must regularly check is interrupted or handle interrupted exception. İşte. Harda kalmıştık. Synchronization enables you control program flow and access to shared data for concurrently executing threads. The four synchronization models are mutex logs, read-write logs, condition variables, and semaphores. Mutex logs allow only one thread at the time to execute a specific section of code or access specific data. Read-write logs permit concurrent read and exclusive writes to read-write log var idi böyle bir şey. Retendant nəsə belə bir şeydir. Protects shared resource. To modify a resource, a thread must first acquire the exclusive write log. An exclusive write log is not permitted until all read logs have been released. Condition variables block threads until a particular condition is true. Counting semaphore typically coordinate access to resources. Count is limit on how many threads can have concurrent access to the data protected by semaphore. When the count is reached, semaphore calls the calling thread to block. Bunun hamısı yadımdan çıxıb bunlar. GP'ye deyib bir daha bunlar hər birine ait bir daha example versin. Give me examples for each case. Mutex log ensures only one thread at the time can enter critical section. Log daha sonra final'da unlock edir. Bu normal bildik. Read-write log, reentrant read-write log. Reentrant read-write log. Bu da ne edir? Read'i lock eləyir, read eləyir, daha sonra read'i unlock eləyir, write'da write'ı lock eləyir, daha sonra write'ı unlock eləyir. Multiple threads can read at once, but writing requires exclusivity. Necə multiple thread can read at once? Hə. Sadəcə read zamanı write olmur. Bunu mu deyir? Threads can wait for condition and resume the signal. Neynir? Lock olur. Ready olanda condition await, waits until signaled. Signal condition lock. Ready true condition signal all. Wake up waiting threads. Neynir? Bir tane thread yaradır. Await condition deyir. Lock eləyir. Ready false ikən await'də qalır. Sonra neynir? Interrupt denir. Interrupt denir. 10 saniye. Yo catch'da interrupt denir. Daha sonra neynir? Signal verir ki ready'de bütün hamısını oyatsın. Burada da gəlir artıq bu condition getdi. Threads waits until a condition is met. Then resume safely. Bu semaforu çox çətin başa düşmüşdüm. Control how many thread can access a resource at once. Only 2 thread can access at a time. Others wait. Semaphore acquires. Okay, semafor 2 dənə boş yer var hazırda. Semaphore acquire bir boş yer qaldı. Sleep eləyir 10 saniyə. Ay 1 saniyə. Daha sonra finally gəlir bura. Nə olur? Release olur. Yenə 2 dənədir. Sadəcə 2 thread eyni anda access edir. Çünki semafor 2 boş yer var. 2 dənə thread run olur. Only one thread in the critical section. Multiple readers but only one writer. Thread wait until some condition becomes true. Limit number of thread accessing to resource. Deməli, tutorials point saytından bax istəyirsən bir də orada kod örnəklər də verilib. Tabii indi baxarıq. Real world analogy with one key. Parking lot with limited space. Create thread by implementing runnable interface. Hazırda baxdığımız mövzu nə idi? Lock. Interrupting a thread, inter-thread communication, thread group. Starts thread in separate path of execution, then invokes run method on this thread object. If thread object was instantiated using separate runnable target, invoked on the runnable object. Start yeni thread yaradıb orada başladır. Run da hazırki threaddə başladırdı. Display message. Runnable run. Following another class with extend the thread. Burada da run implement edeyim. Bu ne? Shows the complete life cycle of a thread. New thread, new start, runnable, run, running, end of execution, dead. Sleep, wait, waiting, sort of dead. New thread begins its life cycle. New state remains in this state until program starts the thread. Burn thread. Biz burada nerede kalmıştık? Buranı bitirdik. Synchronization da ile deməli mutex log falan. Okay. Okay. Bu gitti. Bu nədir? Burada proses nədir, thread nədir? Proses, salam Azad, çox sağ ol. Process Unix environments such as file descriptors, user ID, and so on, created with the fork2 system calls, which is set up to run a program. A sequence of instructions executed within the context of process. A thread interface that is the POSIX threads component. Bu nədir? Bunu anlamadım. Solaris. Bunu birinci dəfə görürəm. Concurrency, parallelism. Buraları oxuduq. Okay. Scheduling, cancellation, synchronization. Yəni gəlin bunu oxuyaq. For application developers, the majority difference between Solaris 64-bit and 32-bit environment is the C language data type model used. For 64-bit data type, use the LP64 model, where longs and pointers are 64-bit wide. All other fundamental data types remain the same as the data types of the 32-bit implementation. The 30-bit data type use the ILP32 models, where ints, longs, and pointers are 32 bits. Long 2 dənəydi. Ona görə long istifadə etmək safe değildi. Çünki 32 bit yarısı 32 bitdə, o biri yarısı 32 bitdə saxlanılır. Hansı ki bu update olub, daha doğrusu thread, multi-threading app'də bu hissəsi update olub, bu hissəsi update olmaya bilərdi. Ona görə bunları volatile eləyirdik deyəsən. The following summary briefly describes the major features and considerations for using 64-bit environment. Large virtual address space. In 64-bit environment, a processor can have up to 64-bit of virtual address space or 18 exabytes. The larger virtual address space is 4 billion times the current 4 GB maximum 32-byte processor. Because of hardware restrictions, however, some platform might not support the full 64-bit of address space. A large address space increases the number of threads can be created with the default stack size. Deməli, large address spaces increase the number of threads that can be created with the default stack size. The default stack size is 1 megabyte on 32-bit, 2 megabyte on 64-bit. The number of threads with the default stack size is approximately 2000 threads on 32-bit system and 8000 billion on 64-bit system. Bu ne demek istiyor? Anlamadım. Okay. Explain this in a simple way. Uzaylırsın görün ne demek istiyor? In 32-bit system, integer long numbers and memory addresses are all 32-bit bytes. 64-bit log and pointer values are 64-bit byte, while int stays 32 bits. The mostly matter for how big numbers can get and how much memory can be addressed. A virtual address space can only see up to 4 GB of memory. 232 4 GB. Okay. 64-bit process can theoretically see up to 18 exabyte of memory. That's about 4 billion times more than 32-bit. In practice, hardware doesn't allow the full 18 exabytes, but still it's much larger. Threads and stack size. Each thread needs some private memory for its stack. Store variable function calls. By default, 32-bit, a thread stack is 1 byte. 64-bit, it's 2 byte. Because 64-bit system can have far more address spaces, you can create many more threads with default stack size. Systems have far more address space, you can create many more threads with default stack size. Bunu necə hesablayırsan? In short, from 32-bit to 64-bit means your program can handle much more memory and therefore create many more threads. The main change for developers are that pointers and long integers are bigger, which allows addressing a vastly larger memory space. Show you practical Java example affecting this. Yes. Deməli, responsiveness, concurrency, performance, parallelism terminləri nə deməkdir? Okay. İndi onlara da baxarıq. Yəni, bu 32-bit, 64-bit bu hissəni bir də anlayaq. Görək bunu necə tapıb. Responsiveness, deməli, application responsive olması deməkdir. Deməli, UI threadlər var, bir də logical threadlər var. UI threadlər əgər arxada qalarsa və logical threadlər məsələn daha çox vaxt ayırırlarsa, bunda responsiveness itir. Amma bunu manage edədiyimiz halda application responsive olur. Concurrency context switchlər baş verir. 2 dənə deməli proses arasında çox kiçik vaxtlar olur. Bir bu proses run olur, sonra o biri proses run olur. Biz elə bilirik onlar ikisi də eyni anda run olur, amma əslində onlar concurrent olaraq run olur. Performance, parallelism. bir də application core və bizim application'ın size-ından asılı olaraq biz neçə thread istifadə etməliyik ki, performansımız artsın, application performansı. Paralelizmdə hər thread proses, daha doğrusu bir dənə core-da run olurdu. Performans da məsələn bizim 8 core var kompüterimizin. Əgər biz bu 8 core-un var və biz 9 dənə thread yaratsaq, bu halda bizim performans düşür application'da. Biz çalışmalıyıq ki 12, 11 əslində səhv bilmirəmsə 11 thread daha yaxşı. Çünki bir dənəsi də context switch və digər proseslər üçün lazımdır. İndi onu da bir dənə dəqiqləşdirək. Onu da mən bilmədim. Dəqiq dedim yoxsa yox. Deməli, nə deyir? Deməli, show those 2000 and trillions numbers are computed and give you small practical Java. How the thread counts are calculated. Core idea, maximum concurrent threads, theoretical. Available virtual space for stack. Per thread virtual memory footprint. For a back of the envelope, people usually divide user space virtual address by the default per thread stack size. Real life is lower due to overheads. TLS okay, bunun bildiği işte 4 GB virtual address. Common rule for the rule of thumb is assume 2 GB, 3 GB user space is practically available to single process. Varies by OS layout. Default thread stack typically baseline 1 megabyte. Division using 2 GB to be conservative. 2 GB'ı 1'e bölürük, hansı ki thread stack'in ölçüsünü assume edirik ki 1'dir, 32'də. Bərabərdir. Belə bir şey. Sonra bunu da bölürük buna. 211, 2000 is the round number. Buradan gəlir ki, belə bir şey. Virtual address is theoretical. Belə bir şey. 38 exabyte virtual addressability on platform. Bunu da 2'ye bölür və belə 10 trilyon mesela belə bir şey alır. You will see 8 trillion and 10 trillions. Bunlar nə idi? Deməli, far more spaces. You can create many more defaults with default stack size. Threads with default stack size. 32'də 2000'e 2000. Burada ise daha çox. Salam Murat. Hoş gəlmişsən. Okay. Practical Java examples. Int and long range overflow. Okay, baxırıq bura. Integer'ımız var. Long'umuz var. Wraps to negative due to 32-bit overflow. Still tiny for 64-bit long. Void matters on 64-bit system. Java long is 64-bit while integer is 32. Anything involving size offset counter that can exceed 2.1 billion should use long. Oy Allah. Estimating thread creation limit safety. Safer math first estimate. Hiç anlamadım buradan. Neyse, bir dənə lazım idi ki, bu 2000 hardan gəldi, trilyon hardan gəldi. O da deyir, 32 bit 232 bir stack, thread stack'teki 1 megabayt'ta onu 1'e bölür. Burada da 64 bit'te 264, thread stack'te 2 megabayt 2'ye bölür. Ümumiyyətlə neçə thread olabileceğini hesaplayır o şekilde. Salam Nuray, çok sağ ol. Bu oradan geldi. Qalan başa düşmədim. Çok kompleks. Buradan devam edək. Kernel memory readers. The kernel is LP64-bit object that use 64-bit data structure internally. That means that existing 32-bit applications that use do not work properly and must be converted to 64-bit programs. Restriction 30-bit programs program that use able to look at 30-bit process but unable to understand 64-bit process. Existing interface and data structure that describes the process are not large enough to contain 64-bit. Such programs must be recompiled as to yani 32-bit program 32-bit prosesör istifadə edirsə, o 64-bit prosesi başa düşmür. Bu tip program must be recompiled as 64-bit program to work for both 64-bit program hem 32-bit prosesör hem de 64-bit prosesör Harda bit gördünsə sadece bil ki 2 üzərinə yaz və nə qədər məlumat yerləşdiyinin həcmini tap. Sonra 2/10 ixtisar eləyə kilobayt, megabayt, gigabayt olarak keçid et. Okay. 32-bit program 32-bit prosesi bu nədir? Bit program process look at whole program can able to look at process what is program and process. Deyir 32'lik sistemde 64 bitlik bir proses eləməyə çalışsan alınmayacaq. Ama burada da deyir ki 64 bit program work 32 bit proses ve 64 bit proses üçün işləyir. Program nədir, proses nədir? Sistem demir axı hələ. Okay. Program compiled for 32-bit environment can read information about 32-bit process. If it tries to look at 64-bit process, it fails. Data structure integer okay are too small to represent the larger bit values. Bit can only hold up to billion, while 64-bit process might need memory address much larger than that. recompile the program as 64-bit program, then it can handle 32-bit and 64-bit process. Program a file on disk contains instructions. A running instance of program. A program can look at process. Program process. Program statikdir, proses işlek haldaki halıdır. Ha, okey. Anladım. Yani mesela burada Note app'i var. Bu programda ve 32 bitdi ve ben bu programı 32 bitli bir prosesdə açanda o orada oxuya bilir. Ya da 64 bitli bir prosesdə açanda but it's unable to understand 64-bit process. 32 bitlik bir programı 64 bitlik bir prosesdə açanda başa düşmür. Çünkü ...32 bit program balacadır, 64 bit program böyükdür. Onları orada reprezent edə bilmirəm. Running an instance of program, it is active memory with memory thread open files, etc. If you open 3 terminal window of running Vim, you have one program Vim but 3 processes. When program is launched, the operating system creates a process from it and gives it resources. Daha çox space'də adresləyə bilərik 32 biti. Amma 64 bitlik prosesləri 32 bit adresləyə bilmərik. Okay. Amma burada deyir ki, deməli 32 bit program 32 bit prosesi istifadə edə bilir. But unable to understand 64 bit process. Yəni bu proqram 64 bit prosesi başa düşə bilmir. Təsəvvür edək ki, bu proqramın 64 bit prosesi yaratıb, onu başa düşmür. Amma 64 bit proqramı deyir ki, 64 bit proqram həm 32 bit proses, həm də 64 bit proses tərəfindən başa düşülür. Necə olur? Əgər proses bir instansdırsa, necə 64 bit olan 32 biti başa düşür? Yəni, soruşaq. If process is instance of program, how 64-bit program can work for 32-bit process, but 32-bit program cannot work for process. Shouldn't it be reverse? Yəqin ki 32 bit proqramda istifadə olunan quantities 64 bitlik olduqda başa düşmür. Hə. Çünki düzdür. Çünki 32 bitlik proqramdakı dəyərləri çevirib 64 bitlik edəndə artıq onlar çox böyük olur və 32 bitlik proqram onlar başa düşmür. Amma proses daxı aktiv olan necə olur? Məsələn, 64 bitlik integer 32 bitlik integerdə yazanda necə ki problem yaranır. Mən elə başa düşdüm, səhv də ola bilər. Process program code on the disk. Process running instance of program. Why 32-bit program cannot read 64-bit process? Data structures, expose data structures. A 32-bit program is compiled with data types that are only 32-bit wide. Yəni bu proqramın data tipləri sadəcə 32 bit uzunluğundadır. 64 bit proses 64 bit uzunluğunda data type'lar istifadə edir. 32 bit proqram bunları oxumağa çalışanda, yəni proqram prosesi oxuyur. Proqram prosesi oxuyur. Proqram prosesi oxuduğu üçün proqram prosesdən daha böyük bitə sahib olmalıdır. Proqram prosesi oxuyur. Can have larger data types. Okay. What do you mean by reading? By program reads process. Can you görək nə deməkdir, nə demək istəyir? Hər bir running process bir dənə folder əldə edir. Proc, məsələn, 1, 2, 3, 4. Information about process with ID 1, 2, 3, 4. Inside are files like status map, CMD lines. So when we say a program reads a process, we mean program opens the file in proc PID, process ID, and interprets the information. Program on the disk, process in the memory. Məsələn, belə bir ID ilə register, stack, heap və bu gəlib bu directory-dədir. Belə məlumatlar var. Proqram da gəlib bu prosesi bu şəkildə oxuyur. Ona görə proqram daha böyük olmalıdır. Nəinki proses ki 64 bitliyə 32 bitlikdə sığır. 64 bitlikdə 32 bitliyə 64 bitlik sığmır. Okey, başa düşdük. Okay. 64-bit libraries, 32-bit applications are required to link with 32-bit libraries, and 64-bit applications are required to link with 64-bit libraries, with the exception of those libraries that have become obsolete. All of the system libraries are provided in both 32-bit and 64-bit version. 64-bit arithmetic has long been available in previous 32-bit Solaris release. Implementation now provide full 64-bit machine register. If application requires only large file support, application can remain 32-bit and use large file interface. To take full advantage of 64-bit capabilities, application must be converted to 64-bit basic thread. Belə. Okay. Burada nə yazıb? Buna da baxa bilərik. Əslində. This chapter introduced the basic thread programming routines for POSIX threads, describe default threads or thread with default attribute values. Ay, keş bu dokumentasiyalar daha yaxşı yazılsaydı. Bunun ağ səhifənin üstündə yazılar. Bu heç olmasa, ne bileyim, bunlar solda olsun falan. Which are kind of threads that are most often used in multi-threaded programming? How to create and use thread with non-default attributes. Life cycle of a thread. When thread is created, new thread of control is added to current process. Every process has at least one thread of control in the program's main routine. Each thread in the process runs simultaneously and has access to calling process global data. In addition, each thread has its own private attributes and call stack. To create new thread, a running thread calls the pthread create function and passes the pointer to the function for the new thread to run. One argument for the new threads function can also be passed along with thread attributes. Execution of a thread begins with successful return from the pthread create function. Thread n ends when the function has that was called with thread completes normally. Buradaki deməli hardaydı? Buradaki bunu izah edir. Okay. Thread can also be terminated if thread calls a thread exit routine, or if any other thread calls thread cancel to explicitly terminate that thread. Thread can also be terminated by the exit of the process that called the thread. Yani ya proses thread'i exit edəcək, ya hansısa thread onu cancel edəcək, ya da ki thread özü exit rutinini çağıracaq. Pthread library, more than 100 function. Section contains the brief description of the function used for basic threads programming, organized according to tasks they perform, and include links to the main page of the associated API functions. Following list directs to discussion of particular task. Creating default thread. When thread object is not specified, the object is null, and default thread is created with the following attributes: process scope, non-detached, default stack, and stack size. A priority of 0. You can also create default attribute object with pthread attribute image and use attribute object create default thread. Anlamadım, bunlar niye böyle diye. Buna ihtiyaç var. Okay. Gel buna bakalım belki. Salam. Çok sağ ol. Okay. Deməli, buraları geçeyim mi? Nasıl buradan devam edeyim mi? For the last 20 years, baxaq gör burada nə deyir. Has had multiple cores in their CPUs. Over time, number of cores has increased. With new console having 8 cores, with hyper-threading and PCs getting more and more cores, with things like IRM servers hitting 80 real cores in a single CPU. Meanwhile, the single-thread performance of CPU has been relatively stagnant for quite a while, hitting a GHz barrier of 4-5 GHz of clock speed in the CPU. This means that applications these days need to be programmed for multiple core to really use the full power of CPU. Okay, multi-core CPU generally has multiple standalone cores, each of them being a full CPU on its own. Each of the core execute arbitrary program on its own. Okay, burada CPU has hyper-threading SMT. The CPU will not execute one thread of program instruction, but multiple, often two. When this happens, the inner resource of the CPU, memory unit, math unit, logic unit, will be shared between those multiple threads. The different core on CPU work on their own, and the CPU synchronize the memory writes from the one core so that other cores can also see it if it indicates that one core is writing to the her bir core öz üzerinde işləyir deməli, and CPU synchronize memory writes from one core so that other cores can also see it if it detects that one core is writing to the same memory location a different core is also writing into or reading from. Okay, synchronization nəzərdə. The synchronization has a cost, so whenever you program multi-threaded programs, it's important to try to avoid having multiple threads writing to same memory or thread writing and one thread writing another reading. For correct synchronization of operations, CPU also have specific instructions that can synchronize multiple cores, like atomic instructions. Those instructions are the backbone of the synchronization primitive that are used to communicate between threads. If you want to learn more about the hardware detail of CPUs and how they map to C++ programming, bu nədir? CPP'dir, nədir bu? Want has C++, know your hardware. 59 dəqiqə. Okay. Ways of using multi-threading in game engines. At first, game engines were completely single-threaded and won't use multiple cores at all. Over time, engines were programmed to use more and more cores, with pattern and architectures that map to that amount of cores. The first and most classic way of multi-threading a game engine is to make multiple threads and have each of them perform their own task. For example, you have game thread which runs all of the gameplay logic and AI. Then you have render thread that handles all the code that deals with rendering, preparing objects, to draw and executing graphics commands. As example, we can see of this is Unreal Engine. So it can be good example. Deməli. Yəni bu iki thread-i sinkronize edir. Eləmək lazım onu deyir. And render thread as main, and then a few others for things such as helpers, audio or loading. Game thread in Unreal Engine runs all of the gameplay logic that developer writes in Blueprint and C++. And at the end of each frame, it will synchronize the position and stats of objects in the world with render thread, which will do all the rendering logic and make sure to display them. While this approach is very popular and very easy to use, it has drawback of scaling terribly. You will commonly see that Unreal Engine games struggle scaling past 4 cores, and in consoles the performance is much lower than it could be due to not filling the 8 cores with work. Another issue with this model is that if you have one of the threads have more work than others, then entire simulation will wait. In Unreal Engine 4, the game thread and render thread are synchronized at each frame. So if either of them is slow, both will be slow as they run at the same time. A game that has lots of blueprint usage and AI calculation. Okay. Bu ancaq desəm oyunun üzərindən gedir. Multi-threading for game engines. Vay, niyə bunu oxuyurdum? Düzdür. Multi-threading oxumuşam, sonrasını görməmişəm. So, search'dən gəlmişəm bura. Olsun, bir hissəsini oxuduq, məlumatımız oldu. Bəli. Exhibit concurrency, some of the required computation. Ay Allah, hardan oxuyaq? GPT'nin verdiği resurslara bax. Neyse, şu an resource tapa bilmem. Buradaki de çok sıkıcıdır. Neyse, buradan devam edeyim. Burası yine çok çirkin yazılı. Thread create filan description. Ne bileyim, bunlar hamısı lazımdır. Burada thread yaratmak için example'lar mı verir? Okay. How the responsiveness resource sharing bunlar var. Multi-threaded programming. Bu yenə yaxşıdır. Bu font da buradakı fontlar normaldır. Bu Oracle dokumentasiyası heç xoşuma gəlmir. Buradakiler çətindir. It shares with other threads belonging to the same process. Its code section, data section. Əslində burada yekunlaşdırmaq istəyirəm, yəni bir qədər oxuduq thread haqqında. Burada gəlin yekunlaşdıraq. Mən gələn dəfəyə çalışım, yaxşı resurslar tapım, oradan davam edək. Belə də bir neçə hissəyə baxdıq. Belə uşaqlar, burada yekunlaşdıraq artıq. Çox sağ olun gəldiyiniz üçün. Hamınız yayında iştirak edildiyiniz üçün təşəkkürlər. Sabah yenidən davam edərik. Çalışacağım yaxşı resurslar tapım, oradan oxuyaq. Ya da mən oxuyub gələcəm, sonra notlar götürəcəm, çalışım onları müzakirə edək. Belə. Hələlik gecəniz xeyirə qalsın. Özünüzə yaxşı baxın. Sabah yenidən görüşənədək.